So yeah, I'm Sanay. I'm a rising junior at Archbishop MIDI. And right now my camera is faced towards the Raspberry Pi because I just wanted to show a live demo, but I'll also just share my screen. So basically when I select an Acura and I open it, so when it submits on the Raspberry Pi, you should see it saying upload file, which means that the image is sent to the Raspberry Pi, and then it'll send back to the NanoNets and it'll return the result. So you can see like it's saying completed 3, and it also says message success, which means it got received by NanoNets and NanoNets was able to send a message back. So when I click get result, you should see 3, and this is an Acura. And I was able to get it with 99.5% accuracy because it also returns the score. And I was able to also do a second picture just to show you a little bit more about like the variety. So uh, when I go to my other image, like this is an Audi, like if you can tell by the like how it looks, it should return 14 and then say this is an Audi. So you can see again, it says upload file, meaning that it's been able to be saved by the Raspberry Pi and it sent it to NanoNets and it was able to get a result. So when I get result, it's able to say 14, this is an Audi, and it's predicted with 99.5% accuracy. And that was pretty much that part of it. And then um, let me share my presentation again. Where is the Yeah, so now explaining like the actual project. Let me just turn my camera, sorry. So the actual project, I worked on an object detection model using machine learning to accurately predict the type of car and specifically the model fit. But the thing is, since I didn't have the NanoNets like uh paid version, it only allows you to have 5 different types of labels. So I was able to choose 5 different types of cars that I wanted it to be able to detect, which is Acura, Audi, Dodge, Ford, and Hyundai. So like for example, if you give it a Toyota, it's just gonna return like unknown, can detect it. So that's one of the things I want to work on in the future is like expanding that data set. And as you can tell from everyone before me, I use NanoNets, which is just a supervised type model. So it basically it is able to define the input based on annotated outputs it gave me. So some of the challenges, one of the main challenges was the Android app. So that was my like main modification. But the thing was like as you saw in my demo video, when it said upload file, I wasn't able to actually get that to print on the Raspberry Pi, meaning that the image was never passing to my web server, which means I would have never been able to get it to NanoNets. So my solution was just creating the web app, which I just demoed. And the other main challenges was uploading the file to NanoNets manually. And the solution was just creating a Python script for that, which would just run a for loop through each of the images. And then based on its corresponding annotations, it would draw a bounding box. So if you see here, it'll just draw a bounding box over all the images. And instead of doing it manually, which would have wasted a lot of time, I was able to get this Python script to actually work and do it for me. And so in conclusion, I just learned a lot more about machine learning because this was actually my first time doing a project integrating it. And I realized like I really like the software problem solving side of it because even though it's really frustrating, like many people have said before me, when you actually solve it, it's like a real experience. And I realized there's so much to explore in computer science as a whole and so many different like hats to do. Like just detection with cars is one thing. You can use it for so many other things. Like pretty much any like object in the world. So yeah, that's pretty much my entire presentation. Thanks. And yeah, if anyone has any questions.
I have a question. So, your web page, did you use Node.js or did you just write an HTML file?
I just wrote an HTML file and I used Flask to set up my Python server,
Okay.
which was on the Raspberry Pi in the demo, but it wasn't able to work here because sometimes it just is not able to like accept anything from the outside. So yeah.
Sanay, what was the most difficult but fun part of your project?
Um, I think getting the model to actually work because I'd never used nanonets before, and it was like really frustrating because at first, like, um, it's like there's the free and paid thing, so I wasn't sure how to get like all 8,000 images into nanonets and like have all these different models. So then I realized I could only have five different labels and models, and then after that, I realized I had to annotate all of them manually. So then I had to go back and write a whole Python script that took a while to write, so it would do it automatically. So yeah, that was probably the most like that was probably the best part and the most frustrating part because when I got it to work, it was pretty accurate, like 99.5% accurate, and then it was just yeah, that was probably the best part.